Section 1.6, Absolute Value Equations and Inequalities. Our objectives for today are to write and solve equations and inequalities involving absolute value. First definition, absolute value. You have two vertical lines around an x. It's the distance from 0 on a number line. It has two parts to the definition. One part is when x is greater than or equal to 0. The other part is when the numbers are less than 0. So absolute value of x equals x if the numbers are greater than or equal to 0. Absolute value at x equals negative x, or the opposite of x, if x is less than 0. And we'll look at that here in just a minute. So we'll use that definition while we do problem number 1. So anytime you see the absolute value, there's going to be two separate parts to solving it. The first one, you write exactly the same without the absolute value. So 2x minus 1 is equal to 5, or 2x minus 1 is equal to the opposite of 5. So you have to change that sign on the right side. We're going to solve each part. So I'll add 1, divide by 2. We'll add 1 again, divide by 2. So with this one, we have two answers, x equals 3 or x equals negative 2. And when it says graph it, they just mean just on a number line. Okay, so negative 2 would be right here, 3 would be right here, and that's it. Definitely when you are looking at these, you should check your answers. So 2 times 3 would be 6. 6 minus 1 would be 5. You have to check, is absolute value of 5 equal to 5? Yes. When you check the other one, negative 2 times 2 would be negative 4. Negative 4 minus 1 would be absolute value of negative 5. Is that still equal to 5? Yes, so they do both work. Here's got it question number 1. You can pause the video, try it yourself, and come back and check your answer. So two different parts. 3x plus 2 is equal to 4, or 3x plus 2 is equal to the opposite of 4. 3x equals 2, x equals 2/3, 3x equals negative 6, x equals negative 2. Also graph the solution. All right, so 2/3 would be right here. Negative 2 would be right there. So just two different points. Problem number 2, what is the solution of this one, and graph it. So, okay, so in order to do this one, don't write it with two different cases right away. You want to isolate that absolute value part before you do it. So I'm going to add 1 to both sides. And divide by 3. So now we're going to write it with two different cases. X plus 2 is equal to 3, or x plus 2 is equal to negative 3. So the opposite of 3. X is equal to 1, or x is equal to negative 5. And then we graph. Here's got it question number 2. You can pause, try it yourself, and come back and check it out. Again, isolate the absolute value first. So 2 absolute value x plus 9 is equal to 4 when you subtract 3. We'll divide by 2. And now we'll separate into two different parts. X plus 9 is equal to 2, or x plus 9 is equal to negative 2. Solve each one. And then you should certainly check them out to make sure they work. So when I put in a negative 7, I get 2 times absolute value of 2 plus 3 is equal to 7. Well, absolute value of 2 is 2. 2 times 2 is 4. 4 plus 3 is 7. That one checks. 2 times absolute value of negative 2. Absolute value of negative 2 is 2. 2 times 2 is 4. 4 plus 3 is 7. Checks out. Extraneous solutions, a solution derived from an original equation that is not a solution of the original equation. So let's look at maybe possibly some extraneous solutions. All right, so when we are looking at this one, notice how the absolute value is already isolated. So we're going to solve for our two different parts. 3x plus 2 is equal to whatever you have on the right side, or 3x plus 2 is equal to the opposite of what we have on the right side. And we're going to solve each one. So when I subtract 4x, I get negative x plus 2 equals 5. And I'm going to subtract 2 from both sides. Gives me 3. And x is equal to negative 3. Or I have 3x plus 2 equals negative 4x minus 5. I'm going to add 4x to both sides, so I get 7x plus 2 equals negative 5. 7x equals negative 7. X equals negative 1. Okay, so when I do that, I want to check to make sure both of those are going to work. So let me change colors. I'll put check right here in the middle. All right, so 3 times negative 3 is negative 9. Negative 9 plus 2 would be negative 7, so absolute value of negative 7. And then 4 times negative 3 is negative 12, and then negative 12 plus 5 would be a negative 7. So absolute value of negative 7 is 7, and that does not equal negative 7. So this one doesn't work. I'm going to also plug in a negative 1. 3 times negative 1 is negative 3. Negative 3 plus 2 would be absolute value of negative 1. And then negative 4 plus 5 would be 1. Well, absolute value of negative 1 is 1, and that does equal 1. So my negative 1 is an answer, but my negative 3 is extraneous. So you always want to check your answers just to make sure. All right, so got it, question number 3. Let's check this one out. Go ahead and try it yourself and check it when you're done. Absolute value 5x minus 2 equals 7x plus 14. So we're going to erase those absolute values out of there and do our two parts. So 5x minus 2 equals negative 7x plus 14. All right. Oops, there should be an equals there. All right, so x is on one side. Negative 2x minus 2 equals 14. I'm going to add 2 to both sides. Divide by negative 2. Okay, so there's my answer so far. You could check it right away if you wanted. Then we have 5x minus 2 equals negative 7x minus 14. That gives me 12x minus 2 and then we'll add 2 and divide by 12. So my two answers, I think, are -8 and -1. And now I'm going to check it out to make sure they work. Okay, so check. Put it into the original one, not anything that we've just written. So -40 minus 2 would be absolute value of -42. And -56 plus 14 would be -42. Well, absolute value of -42 is 42, and that does not equal -42. So -8 is an extraneous answer. And now I'm going to put the other one in. We have -5 minus 2, that would be absolute value of -7. And then -7 plus 14 would be 7. And then 7 does equal 7. So -1 is your answer, and you would be able to call it quits right there. A compound inequality can be written from absolute value of x less than 5. Basically, you're going to write it -5 and 5. Those are your outer limits, and you put less thans for both. It's also the same as x is greater than -5 and x is less than 5. So you can also say right here, x is between -5 and 5. Use the one that I have written in blue over the two-part one. So the book likes us to write them like this rather than like this. So write the one like in blue. All right, so problem number 4. What's the solution of absolute value 2x minus 1 less than 5? So we're going to write a two-part inequality here. The 2x minus 1 will go in the middle. You're going to do less thans. 5 would be on the right. -5 would be on the left. Now, when you're doing this one, you're going to be adding 1 to both parts. So when I try to isolate the x right here, I need to add 1, and add 1. So -4 less than 2x less than 6. Now I'm going to divide by 2, divide by 2, divide by 2. So -2 less than x less than 3. So when we're looking at this one, it is those numbers between -2 and 3 not including those numbers because it's strictly less than. So all the numbers in between those. Here's got a question number 4. You can pause the video, try this one, see if you can get it right. So we have -8 less than or equal to 3x minus 4 less than or equal to 8. So we're going to add 4 to every part. Divide by 3. -4/3 less than or equal to x less than or equal to 4. On the number line, that would be like -1 1/3. So this time it's equal to 4, and it's also equal to -1 1/3, and it's everything in between. Problem number 5, what's the solution of this one? Now notice the symbol on this one. In the previous couple of examples you had less than and less than or equal to. So if you have a less than there, it's between the two intervals. If you have a greater than, it means it's on the outer edges. So with this one, we'll have two different parts. 2x plus 4 greater than or equal to 6, or 2x plus 4 less than or equal to -6. So you flip the inequality symbol over and you add a negative and you solve each one. So subtracting 4 and dividing by 2 gives you x is greater than or equal to 1. And subtracting 4 on this one would give me -10 divided by 2 would give me -5. So -5, there's 0, and there's 1. All right, so it means we have a dot here, and we are shading this way. We have a filled in dot on 1, and we are shading to the right. Got it, question number 5. Why don't you pause, try this one, and then come back and check it. So it's greater than, so we're going to have the outer two edges, 5x plus 10, greater than 15, or 5x plus 10, less than -15. We'll solve each one. 5x is greater than 5, x is greater than 1, or subtracting 10 gives me 5x less than -25, x less than -5. Okay, so it has an open circle on 1 shaded to the right, an open circle on -5 shaded to the left. Now, just a little quick summary. Absolute value of x equals a is going to be 2 points. It's going to be x equals a and x equals -a. Okay, so if we had a sample question on this one, like absolute value of x equals 2, that would be x equals 2, x equals -2. Okay, just like that. If it is a less than, it's going to be the points in between the numbers. So for this one, you're going to have x is less than a is less than -a. Here's an example. Absolute value of x is less than 4 would mean -4 less than x less than 4. Open circle on both of them, shade in between. And then when you have a greater than, you have x is greater than a or x is less than -a, and you're going to shade the outer edges. Here's an example. Absolute value of x greater than 2 would mean x is greater than 2 or x is less than -2. And shading the outer edges. Just like that. Now, tolerance is half the difference of the maximum and minimum acceptable values. In car racing, a car must meet specific dimensions to enter a race. Officials use a template to ensure these specifications are met. What absolute value inequality describes heights of the model of race car shown within the indicated tolerance? So check out the picture on page 45. The desirable height is 52. The greatest allowable height is 53. The least allowable height is 51. So to find the tolerance, you're going to take 53, the greatest, minus the least, and divide it by 2. So 2 divided by 2 is 1. So the desirable height is 52. So h minus 52. And you're going to have a tolerance of 1. And then you go ahead and you write that as a absolute value question. So we add the absolute value, h minus 52, and it's going to be less than or equal to 1. So that would be the absolute value inequality for that particular question. And that's it. So bring questions tomorrow with you. We can get those answered in class.